Good day, and welcome to Africa Teen Geeks. My name is Nonkululeko Madondo. I am your teacher for Physical Sciences Grade 12. This is your class from 12:30 to 2:30, where you'll be having me join you here. Today, we're going to be doing matter and material, which we have started 3 weeks ago. And this week, you're going to be doing organic reactions. We first started off with organic molecules, and then we went through to organic properties, which is what we did last week. And today we're doing organic reactions. Just reminding you guys that with matter and materials, this is part of your paper 2 of the exam, and this is plus or minus about 30 to 40 marks of your paper when we combined all 3 of these lessons joined together. Okay, so it's very important. It's stuff that you guys have to know. I am Nonkululeko Madondo, and I am your teacher for Physical Sciences Grade 12. And thank you guys for joining me here. So getting started, I hope that everybody has had a great time getting to understand all the work, etc. So on this lesson, we're going to be focusing on the following: the substitution reaction, addition reaction, elimination reaction, and combustion reaction. So what are these, guys? These are the reactions that we're going to be working with for this chapter. Okay. So we need to, basically, this is what we're going to be working with today. So we've done the molecules, the changes, the bonding, we've done all of that. Now we're getting straight to the reactions. So there's just a few terminologies that I'd like us to go through. Okay. This is all the terminology that we're going to be working with. Okay. So in this chapter, the first one, what you need to know is, what is substitution reaction? A chemical reaction which another atom or group of atoms is substituted by an atom or a group of atoms in a molecule. So the replacement of parts of a molecule. So you guys understand, means that a chemical reaction which another atom or a group of atoms is substituted by an atom. So basically here it means that if you have the hydrogens and the last hydrogen, maybe we'll change the last hydrogen and replace it with a chlorine. That's an example of a substitution reaction. Okay. So the second one, we're going to have our addition reaction. I'm sorry about that. It's addition reaction. Addition reaction is a chemical reaction in which a molecule binds to a second molecule's double or triple bond to form a single molecule. So the double or triple bond is breached during the reaction, and the new atoms are added to the molecule to form a more saturated substance. You remember we worked with saturation before, and you know that a saturated substance is a substance that has only single bonds. So combination of 2 molecules into 1 saturated molecule. Okay. So now we move on to the next one, which is an elimination reaction. Guys, what we're doing right now, I'm just going through the terminologies so that once we get through into the work, things don't look new to you guys. Everything becomes, just a reminder. Oh, substitution is where we replace something. Addition is where we take 2 and form to 1. Elimination is the removal of a small molecule from a big molecule, splitting a part of an organic molecule to make an unsaturated product. So what are we doing now? Now we are taking, once you see unsaturated, you already know that now we're going to have double bonds. So this makes sense why our molecule becomes molecule. So you have 1 molecule and it's going to end up becoming two small molecules, unlike, which is basically in contrast to the addition reaction, where you take two molecules and add them together to form one. In this case, you take one big molecule and you divide it into small pieces. Okay. So now we've got the next one, which is our combustion reaction. A combustion reaction is a chemical reaction in which a material responds quickly to oxygen and induces light and water. So what does this mean? This means that now we are working with a burning reaction, whereby whatever material, whatever substance we have will react with oxygen, and this will give us light and water. Light could be fire, light could be an explosion, it could be any one of those things. So that will be our combustion reaction. And then we move on to our substandard reactions that we have there. Our hydrogenation. Our hydrogenation, this one, you can take notes here. It says the addition reaction. So this means that this is part of our addition reactions in the presence of a suitable catalyst. So which means that in a hydrogenation, you need a catalyst when hydrogen gas is applied to an unsaturated carbohydrate. So basically, we know that your catalyst is going to be used to form one single bond. So the catalyst is what is used to break the double orbital bonds and for it to reform into one saturated molecule, like we've already mentioned over there. Okay. So the next one is hydrohalogenation. Okay. So this is an addition of halides. Okay. So don't get confused, grade 12s, when you see halogenation and hydrohalogenation. That one is where we work with hydrocarbons added to a halogen. But now with hydrohalogenation is the addition of halides or anhydrous halogens to create alkyl halides. Okay. So make sure you take note. So make sure you take note with regards to the hydrogenation and hydrohalogenation. So the third one is hydration. Okay, this one is a much simpler term to remember. Is the addition of water to an unsaturated hydrocarbon in the presence of an alcohol generated catalyst. So you see what's happening here, guys. In most cases, we are dealing with for us to do an addition reaction, for us to add two molecules together, basically we need a catalyst that will be able to break the unsaturated bonds, because these ones are dealing with unsaturated bonds, hydrocarbons, and they need a catalyst that's going to break the bonds and form it into one single bond. Okay, so now we get to the term of saturated, like we've been mentioning before. A hydrocarbon that only has single bonds between the carbons. And an unsaturated is a hydrocarbon which contains double or triple bonds between atoms of carbons. Okay, so catalyst, like I've already mentioned here, when we talk about addition reaction, we need a catalyst. It's a chemical used to speed up a reaction but not change the molecule. What does that mean, guys? It means that, like we mentioned before, it will speed up the reaction for the bonds to break in a molecule, but it will not add any chemical or change anything. It will just speed up the breaking of the bonds so that they can reform, which was obviously going to be done originally, but it wouldn't be as quick as when you add a catalyst. Okay, so catalyst is just something that adds on. Okay, it adds on the speed, it speeds up a reaction. So the next one is a reagent. A reagent is a chemical that has been used to react with another. Okay, so that's what we have so far. So the reagent is a chemical that has been used to react with another. What does reagent mean? Don't forget, you're still going to work with a lot of reagents, especially in our chemistry part. You're going to see a lot of that. It's a chemical that has been used to react with another. So if, for example, you have X plus Y equals to XY, what are going to be our reagent? It's going to be our X or our Y. One of them, because they are used to react with another molecule to form something in our product side. Then what's a reflux? A reflux is a process of boiling a mixture and allowing the solvent to condense and fall back into the mixture. So the process of boiling a mixture and allowing the solvent to condense and fall back into the mixture. For example, you've got a glass that you can boil, for example, when you try to separate, when you see the solid particles will probably fall down to the bottom once it becomes once it has cooled off, right? And the liquid part will be on the top, and that will be you'll have your solvent and your solid. Okay, so what's a polymer? A polymer is a long chain of repeated pieces made by addition or esterification. You're going to see most of that as we go along into the lesson, but we're not going to be doing plastics and polymerization today. We're going to do that next week because it's going to be too much work for our 2 hours, considering that we still have to do some revision question of our exam. Okay. Now let's move on. So we're going to start with our first one. I've included a drawing here just to give you guys a short mindset of what is happening, okay? So we're going to start with the first one, which is our substitution reaction. So we've got a substitution, we've got an addition, and we've got an elimination, okay? So a substitution reaction is a chemical reaction in which an atom or group of atoms is substituted or substituted by another atom or group of atoms in a molecule. Only under 2 conditions: in the presence of sunlight or ultraviolet light at a temperature between 250, this is 250, 2000 Fahrenheit, sorry about that. It's 250 degrees. So this is actually the small o, I forgot to fix it. And 450 degrees Celsius is a substitution phase possible. Okay, so you can only substitute it once it's between, the substitution can only occur between these 2 temperatures. Okay, so the hydrogen atom is substituted in the alkanes by a halogen atom to form 2 compounds, one of which is a haloalkyne and the other one is or it could be a alkyl halide. Okay, so there we have it. This is going to be your molecule, your first one and your second one. So what are we going to have from there? We're going to have this one will substitute the first one, which gives you this, and this second one will be substituted with this one. So you see they kind of like swapped some molecules. Okay, so it's just like this one, an example here. It's going to be like saying CH4 plus Cl2 with our little catalyst will give you CH3. So you see they just took one C, one chlorine, and replaced it with one H, and took the one H and wrote it here. So they substituted both. So nothing was lost, nothing was minus. They just replaced each one of them. So the number of products and reactants are equal. Okay, because you're substituting, you're not removing and you're not adding. Okay, you're not removing and you're not adding, you are substituting. So whatever, if you have two reactants, you will have to have 2 products. Oh my word, I made another mistake here. It's products. Ooh. Okay, so the reactants are saturated, products are also saturated. Okay. And then to transform alkanes into useful starting materials for other organic molecules, substitution reactions are used, okay? So esterification is a substitution reaction that creates esters. So which means esterification is also part of our substitution reaction, but in this case, we are creating esters. Remember, esters is COO. The COO, it's got double O's and another O bond. Yes. So these compounds often smell sweet or fruity, or are also used in foods or perfume. Okay. So those are the things that you guys have to remember. Okay. So esterification is a substitution reaction that creates esters. So just remember, great child, I know sometimes you might forget what kind of reaction it is, but always remember it's a substitution, because you will get a mark. You won't be able to get a mark for saying a process whereby esters are created. No, I've seen in the past, there's been students that write answers like that. We do not write it like that. You must write it in full. It's a substitution reaction that creates esters. So why do we need to write substitution reaction? Because once you write substitution reaction, it will make sense, because once you write substitution reaction, we can already think of the definition. We now know that, oh, it's a substitution reaction because we take one molecule, we replace it by another, and the other one also gets replaced by another. So that is a process whereby at the end we will form an ester. Okay, so these compounds often smell sweety or fruity, so it's a very sweet taste type of reaction. Okay, so getting into our substitution reaction, like I mentioned, it's compounds with single bonds, alcohols, alkanes, or haloalkanes form compounds with single bonds to form different homologous series. Okay, so here is our example over here. Okay, so this is going to be our answer that we have right here. So this is what they're going to give us. Getting back to our arrow. So the first type of substitution reaction is going to be our halogenation alkanes to haloalkanes. And that, for example, remember our alkanes to alkanes. So this is our alkanes and this is our haloalkanes. So it's going to be Br2 plus methane. This is methane, right? Because it's got single bonds and it's got one carbon and it's got H's. So what we're going to do, we're going to replace our haloalkanes. So just take a look at these ones. So you see the reaction condition is going to be heat, sunlight, or UV rays. But check here what happened. They replaced one Br with H, and they replaced the H with one Br. So this is substitution. You still have two reactants or products, and you still have two reactants, and you still have two products. You just substituted amongst the two. Okay. So the next part of our problem, we're going to have our hydrolysis. So that one, it was the halogenation, you know, it's where we have our halogen. But now we move to hydrolysis. Okay, so hydrolysis is it's a much longer one. It's a much longer one. it's going to be like this, and because haloalkyne, it's going to be a haloalkyne to an alcohol. So here we're going to have it. You see, this is our haloalkyne. It's got our Br, and we're going to add it to H2O, and we're just going to do a small substitution there. We're going to substitute the Br with one of the H, with an OH, which is going to be our alcohol, and there we have it. You see, there's our alcohol, and so we took the one OH, we put it there, and we took the Br and we put it up there, and that will give us this structure with our alcohol plus our HBr. Okay. I hope that you guys are all with me and you're understanding what is going on here. So moving on to the next one. So I hope that you guys are able to follow through what I have written there. Because now we're moving to the next one. It's where we hydroalkane to can have so hydroxide, and this one we've got our Br there, right? So our product in the end, we're gonna have our OH. So once you have, once they tell you it's a hydrolysis, once they tell you that it's a hydrolysis, what they want from you, it means that once they ask about the hydrolysis, you're going to have an alcohol with this. And they said use the hydrolysis to do a substitution reaction. You know that whatever you're substituting has to be substituted with a, whatever you're substituting needs to be substituted with a alcohol, which is an OH. You know by now, grade 12, that OH is for alcohol. Okay. Then now we're moving on to the 1.4, and that one is a alcohol to haloalkyne. Okay, so now we have an alcohol to haloalkyl, and this is one way they already have an alcohol, right? And you have your HBr. So this one basically, it's sort of like a reverse of this one that we did in the beginning here. Okay, so this one will require heat, but with this hydrolysis, the alkanes to alcohol, it dilutes strong base NaOH, KOH plus mild heat. So once you see, for example, in an exam, and they show you a reaction like this, and they tell you that there's NaOH or KOH or LH plus mild heat, then you know that this is a hydrolysis reaction. So this one is excess H2O plus mild heat. So there's always heat that is required for these reactions to take place. Okay. Okay. So now we're moving on. Now we're moving on to our next part of our reactions. Now we're going to be doing addition reaction. So what do they say? They say for an addition reaction to form saturated compounds, unsaturated compounds undergo addition reaction. So now I'm sure that you guys are quite familiar to form saturated. So it means that now we're looking to form a molecule that has single bonds, right? And single bonds. And now we need to form double bonds. Undergo so for us to form our single bonds, we're going to have molecules. Maybe here we're going to have a CH that has triple bonds and plus something else that had double bonds. But once it forms into one, they all become single bonds. Okay, so the bonds need to break. Okay. Okay, so now we move on. It says here, if you check here, you can see what's happening. You took these two and you added them into one molecule. So it says unsaturated reactions, double or triple bonds result in a saturated product, which is our single bonds. So number one, we've got hydration, and hydration, this is what we're going to have. You see what's happening here? We've got two ethene. This is ethene because it's got a double bond over there. So this is our ethene. It's got two CH, it's got double bonds there, plus H2O. That will give us, we're going to add them all together, plus OH. As you can see, it's going to be, hydration is one way we add water. Okay, whenever you add water, whenever you do hydration, you are adding water to your reaction, and this is what you're going to have. So you see, now they're all going to have single bonds because of the addition into this reaction. And then hydrohalogenation, number two, it's hydrohalogenation. This one, once again, we've got our double bonds over there and plus HCl, okay? That will give us our single bond. So HCl, this one, remember I told you guys, hydrohalogenation is one way we add a halogen there. Okay, so our all of those ones are our halogens. So that's what we're adding over there. We're adding an HCl, and that will give us this molecule. Okay, and then now we go to halogenation. Number three is hydrogenation. Okay, so be careful of these terms. They're very confusing. You just need to be able to decipher what each of them mean, and you'll be able to understand. So hydration, you know you add water. Hydrohalogen, you know that you add a hydrogen. You see hydro, this is what you have there. Halogen, and that's what you have there. So be careful, guys. Do not make those kind of mistakes. Okay. Let me just try and show you guys. So here, we're going to have our hydro. I just want you guys to always remember this, okay? You see, so this is our hydro part of the name. And then we're going to have our halogen, halogen, and this is going to be this part of the. So do you guys see now? Do you see what I've been trying to explain? So what we're going to be having now, we're going to be having our hydrohalogenation. Okay, so on number 3, we're going to have our hydrogenation. Guys, I'm just trying to break this down for you guys so you guys can be able to remember. So once you see hydrogenation, it means we're going to add a hydrogen to a halogen, and all of that is we're going to be adding it to a alkane, an unsaturated, which is an alkene or alkyne. Okay, and we're going to have our single bond there. And for hydrogenation, hydrogenation is not tough, is not really hard to decipher, because hydrogenation, we already know. Remember, we had hydration, but hydrogenation, it means that we're going to have our H, we're just adding our H2 atom over there. Okay, so do you guys see? It's not difficult to remember these hydro, because there's many of them. But once you start understanding what each name means, you will not have a problem. Okay, so let's see the halogenation. This one is also pretty much self explained, right? The halogen is gonna, we already know, it's very simple. We are adding a halogen into our alkene or alkyne. Halogen, as you can see, there's our halogen, you see. So do not confuse the hydrohalogen and the halogenation, and do not confuse the hydrohalogenation and the hydrogenation. So you guys see the difference between the 3 of them. I hope that you do, because this is exactly what you're going to have in your examination, and it's stuff that you're going to have to know off by heart. Okay. Okay. And then now, this is let me see. Okay. Oh boy. Okay. Substitution reaction. Okay. So we're still good. We're moving on. So this is our table that summarizes all of it, right? This is our table that summarizes the stuff that we've just spoken about. We've got our hydration. We know hydration is where you add water. Just think about being dehydrated and needing water for you to survive. So that is a hydration reaction. And then we've got halogenation. That's where we add a halogen, as you can see here. We've got Cl2, unreactive with solvent, Cl2, and we substituted. We add them here. We don't substitute. We add whatever you have. You add it all together, so everything becomes one. There is no 2 products. There's no 3 products. Check whatever is added, and it becomes one. So there we have it. So there, like they mentioned, there for hydration, you usually see with a catalyst of H2SO4, H3PO, or H3PO4. Then you know that it's a hydration reaction. But with halogenation, unreactive solvent, you'll know just by looking at the double bonds there and the hydrogen and the halogen there that it's a halogenation. Then hydrohalogenation, remember what we said? We've got our hydro, which is H, and halogen, which is Br, and we add it to our bonds over here. They'll also all give us a single bond. So no water, unreactive solvent. So this one, you're going to add a hydrohalogen. which is HBr. And then you've got our hydrogenation. Our hydrogenation is going to be our one where we add our hydrogen atom, which is going to be H2. So we don't just add an H that is standing alone, H2, okay? Even with our halogen, it's not going to be just one Cl, it's going to be Cl2, okay? Remember that. And here, we always have a catalyst as PT, PD, or nickel, okay? So all of these can be any one of your catalysts. Make sure that you get it right. So we're moving on to the next part of our reaction. But before we go there, there's just something that I want us to go check out in our textbook. Remember, guys, I always mention to you guys that in this classroom, we use the Siavula textbook, use the study and master textbook, but any other textbook that you can get your hands on that is CAPS approved, you guys can no doubtedly use, okay? So here, I'm just going to go to our Siavula textbook. No, I'm going to the study and master textbook. Yeah, here we have it. There's just a reaction. I think it's yes. Okay, no. This is going to be part of the elimination. Okay. Let me just see. We're still getting to it, right? Okay. So no problem. We're still coming there. So now I hope that everybody is sorted when it comes to the addition reaction. Okay. So we first started with our substitution, where we just substitute one molecule with another one, and one substance with another one, and we came to addition, where we take whatever is added together, we add it together to form single bonds. So it's usually unsaturated bonds into single bonds. So now we're moving on to the next lab, which is our elimination reaction. So the elimination means that a smaller molecule is separated from a bigger molecule. Okay. Elimination means that a smaller molecule is separated from a bigger molecule. An example of an elimination reaction is the cracking of alkanes. Okay, so when it comes to elimination reaction, like we spoke in our introduction, when we were still doing our theory questions, elimination reaction is the exact opposite of our addition reaction. So remember, with addition reaction, we had these two molecules adding together to form one molecule, but now we are doing an elimination reaction. So what will happen? We're going to have one big molecule that has single bonds, and it's going to be chipped off into either 2 parts or 3 parts or whatever parts to form many bonds. So you're going to get unsaturated bonds, which is triple. You're going to have a saturated molecule, which is obviously single bonds. That's going to break down into unsaturated bonds, triple or double bonds. Okay. So they say elimination means that the smaller molecule is separated from a bigger molecule. An example of an elimination reaction is the cracking of alkanes. Okay. So cracking is when molecules are divided into molecules with smaller molecular masses with large molecular masses. So cracking is when molecules are divided into molecules with smaller molecular masses with large molecular masses. Okay. Okay. So the next one, it says, as you can see, like I've already explained to you guys, you got this one big molecule that has single bonds. So it has to break down, right? When we eliminate, we are breaking down the bonds. So for us, after we break these bonds, it's going to give us many molecules. It could be two, it could be three. You'll see in the future, but it's going to break into two molecules. And you're going to have molecule A and molecule B. But these molecules, they're going to be joined by either double bonds or triple bonds between each other, okay? So it says a useful method of processing ethene. So when ethene is processed, the starting material of polythene is to extract water from ethanol. So this is also an elimination procedure. So cracking is a mechanism by which hydrocarbons are eliminated, making chains from longer ones shorter and more useful. Through doing so, we can use the longer hydrocarbons as fuels, starting materials for plastics present in oil. So like I mentioned, we're going to speak more about plastic and polymerization next week when we do the lesson on that. But for now, basically they're telling you that sometimes things have to be broken down in order for them to be more useful in a smaller or longer hydrocarbon chains and smaller mechanisms, okay? So for example, here you've got this long chain and you're going to break it down into two chains. So this becomes more useful, okay? So compounds with single bonds form compounds with double bonds or triple bonds, etc. Okay, so from saturated to unsaturated. That is our elimination reaction. Okay, so types of substitution. Okay, so we've got the dehydrohalogenation, dehydrohalogenation, dehydrohalogenation. So you guys must just check. Remember we had before on our addition reaction, we had hydrogenation, hydrohalogenation, and we had hydration, and we had hydrogenation. In this case now, everything is going to be now in reverse. So now we're going to have dehydrohalogenation. Let me just get a marker so that I can highlight. Okay, I'm just trying to get a highlighter so that we can, oh no, I took the wrong thing. It's still the highlight, okay. So remember when we talk about D, we talk about minusing it, right? So that's our D hydro. So let me just get our D hydro, and there we have our so we are removing the hydro, and we're also taking out and hydrogen there. So you see dehydro, and let's change the color so that for the halogen, guys, the reason why I'm doing this so slowly and highlighting each and every part is so that you guys can be able to see the difference. Okay, so there we have it. So now we are we are taking out. So we had our um we had our okay, so we had our, we are minusing. Here we've got our Br and we've got our H. So once we do a dehydrohalogenation, we're going to be removing our hydrogen and our halogen from this part to form H2O, right? So what do they say here? They say for this, the reaction conditions for this one, it's going to be sodium hydroxide, potassium hydroxide, and lithium hydroxide, right? In ethanol and heat. Okay. So once you see a reaction like this, plus NaOH with heat, or if they could have said KOH, or they could have said LiOH plus heat, then you'd know that this is a dehydrogenation, dehydrohalogenation. Okay. So what are we going to do next? We've got our single bonds, like they mentioned there, to form compounds with double bonds. So there is our double bonds there. Let me just indicate. We always work with the theory against the what we see there. Okay. Okay. So there now we've got our, let me just change the color. Don't want a dark color. Okay. So there we have our double bonds there. Okay. And then now we've got NABR and H2O. So these are the, I'm highlighting the most important parts that we have after this reaction. Okay, so we're going to have, when we dehydrohalogenate, it means that, remember when we were hydrohalogenating, we were adding them into our molecule, but now we are taking them out. So we're going to have our double bonds, and we're going to have our NABR plus H2O. Remember, on dehydrohalogenation, there must be a hydrogen, there must be an H2O as well. Okay, so there we have it there, our H2O, NABR, and this is what we have for our dehydrohalogenation. Okay. Then now we're moving to the second one. We're still going to get to the other ones, but or should we just jump? Let's jump to dehydration, right? While we're still on the dehydros, let's go to dehydration. Let's see for 3.4. Dehydration, we already know hydration is where you are thirsty and you need water. So in your addition reaction, you are adding water into your reaction. Okay, so dehydration is where we have a molecule, but there's too much water, so we're going to sweat it out. Okay, so dehydration is where we take out water from a molecule. Okay, for example, here, as you can see there, we've got this one big molecule, and there's our OH there, which is our alcohol. It's using the dehydration agents, guys. Please, grade 12, whatever you do not forget your catalyst that you use for each reaction, because sometimes they can give you a catalyst and ask you what kind of a reaction comes from this catalyst. These are the things that you got to know for your exam, so they're very important. Just make sure you get them right. Okay, so for example here, dehydration, it's going to be Yes, so you see, within our dehydration, we're going to have our water. There we have it. Our result is going to be H2O, and it's going to be a unsaturated bond over there. Okay, so with the dehydration, we are removing water. Halogenation, we are removing water and we are removing the halogens, right? So dehydration, we're only removing water. Okay, so make sure you get your understanding, okay, of the concepts. So there is dehydro. Then now we're moving to dehydrogenation. Okay, dehydro. So we're already starting to decipher the term. So now we already know that it's dehydro. What do we know about hydrogenation? We already know that in hydrogenation, we are adding the hydrogen atom, okay, the H2 atom. So now that we are dehydrogenation, it means that we're going to be removing the H atom, okay? We're going to be removing the hydrogen atom, which is going to be the H2. So there we have it there. It's going to be CH3, CH2, CH3 will give you see, there's our double bond there, plus our H2 atom. So this is the catalyst that we're going to use here is PT, right? Make sure you remember, guys, please. Please get all of this right, guys, so that we can move forward. Okay. So please, guys, make sure, because once you do not understand the terms or whatever is asked of you in the exam, you will not be able to do it. Okay. So you need to know these. You need to know these very well so that you can get it right in your exam. Okay. Okay. So our PT, we have it there. So just remember, when you think of PT, just think of your platinum, right? So you have your platinum. Once you use your catalyst as a platinum, then you know that you are doing your dehydrogenation. Okay. So now we're going to move on to, let me just remove this. It's very disturbing. Okay. Now we're going to move back to our thermal cracking. Okay. Remember we spoke about cracking. Let's just go back. Yes. We said cracking is a cracking cracking is a mechanism by which hydrocarbons are eliminated, making chains from longer ones shorter and more useful. Okay, remember this part. So now we go back and check out how we perform thermal cracking. So we're taking, you see how long this chain is? By definition, we're taking hydrocarbons from long chains and break it down into shorter chains, like they mentioned there, by which I eliminated making chains from longer ones shorter, more useful. Okay, so now this chain, we're going to break any one of them there, right? And we make them shorter so that they can be much more useful. So what do you need here? You only need your heat and high pressure. Okay, so high pressure. Why do you need high pressure? High pressure is the one that's going to be breaking down the bonds of each molecule. Okay, making sense? So we've got two types of cracking, right? We've got the thermal cracking and we've got the catalytic cracking. Okay, so what is a catalytic cracking? Catalytic cracking is this one here, where we actually have a catalyst. The thermal one is the one where we use heat. Remember, thermal means heat, okay? So just remember it using those terms. So catalytic cracking will be this one right here. It's going to be the CHs, the long chain. We're going to use heat and a catalyst. Our catalyst is going to be any one of these two. It's going to be alumina or silica, okay, and heat. And that is going to give us ethane plus ethene. Okay, so we've divided them into two molecules. We're going to have ethane, which is the one that's going to have single bonds, and ethene, the one that's going to have double bonds. Okay, so while we're doing this, we're making it more useful, breaking it down into smaller chains, shorter chains, to make it more useful. Okay, are we all good to go, guys? All is good. Now we're moving on to our combustion reaction. Okay, our combustion reaction, I didn't dwell too much on it. Oh, but before we go there, now we can do our exercise that I mentioned to you guys. That is on the study and master textbook. If you do have a study and master textbook, you can follow through here. Okay, it's quite slow today. I don't know, Snaplify has days, but it's a great application. If you're still struggling to get some of your textbook, make sure that you get yourself your Snaplify and you can get all your textbooks. It will be useful, especially with the end of the year exams coming up. You do need Snaplify. Make sure that you make use of it. There we have. So you do not just get textbooks for physical sciences, but it could be for all your other subjects as well. There's multiple textbooks. There's a range of textbooks, absolutely free until the 31st of December, 2020. So if you're in matric now, you have to take advantage of the situation, okay? I don't know if I'm moving too fast or moving too slow, but it's... Yes, here we are. So here's a reaction, just a small exercise to move us from the theory, from the too much theory that we've been working on. It says there, when ethanol vapor is passed over a hot porous ceramic surface, both the CO and CH bonds are broken and ethene and water are produced. So the ceramic surface acts as a catalyst. Okay, so our catalyst here is a ceramic surface. When ethanol vapor is passed over a hot porous ceramic surface, both the CO and CH bonds are broken and ethene and water are produced. Okay, so there we have our reaction over there. It's going to be our ethanol, OH, ethanol. Okay, how do we know it's ethanol? It's got two C's, two carbons, and it's got an OH. So it means this is our ethanol. And our catalyst in this case has been mentioned to be the ceramic surface. So the ceramic surface speeded up the reaction, which gave us ethene and water. So there we have our ceramic wool soaked in ethanol. This is our pumice. And this is the heat. This is where the heat goes through. And ethene gas collected by downward displacement of water. Okay, so the ethene is a gas. So the gas gets formed over here. So you see under high pressure, this is water, and this is the small pipe you use so that the pressure can build up in there, enough pressure so that the gas can move up in the tube. Okay. So that's how our equation will look like for dehydration. There's another dehydration reaction. You see there where you took pentanol and you take out the H2O. But remember, you see what we have, the dehydration will always be H2SO4. Okay. Okay. So I want to also check an example of thermal cracking and catalytic cracking. As you see here, they say breaking up large hydromolecules, smaller useful unsaturated compound is called cracking. See, smaller and useful compounds. So the product depends on the temperature, pressure, and presence of catalyst during the reaction. So thermal cracking uses high temperature without a catalyst, and catalytic cracking uses lower temperature. Oh, guys, these are things that you guys must bear in mind. Okay. The thermal cracking uses high temperature, no catalyst. The catalytic cracking uses low temperature and pressure in the presence of a catalyst. So when we look at this example here, it says ethene is used in industry as a raw material to produce polyethylene. Okay, polyethylene. But here we said polyethylene so that you understand that we have ethene already in here. Okay. So ethane is cracked in a steam cracking furnace in the presence of steam at a temperature of about 800 degrees Celsius to produce ethene and hydrogen gas. The ethene can then be polymerized to form polyethylene. Okay, so you see here what they used. They took very high temperature, which is steam in this case. They took the ethene and they broke it down into, and it gave us the ethene plus H2 gas. Okay. And then let's see. So this one is our thermal thermal cracking, because here we steamed it in the presence of steam at temperature of 800 degrees. So here we only use steam, so which means we only used our thermal method. But check on this second one. It says large straight chain alkanes can be cracked to produce shorter chain alkanes and branch alkanes, which are more suitable for use in petrol. Decane and other hydrocarbons with large molecules are catalytically cracked to give alkenes, which are better fuels, and other useful chemicals. Many catalysts can be used, for example, platinum, iron, nickel, all of these ones. Okay, so they say here decane is like this, right? It's going to be CH3, CH2 in the bracket 8CH, and this is going to be our catalyst. Our catalyst in this case is going to be platinum. Okay, that's going to give us ethene plus octane. So it didn't change much. All it did, it just broke up the chains into two parts that can be more useful to use. Okay, are we good to go? Do you understand now the procedure of? Okay. Then now we're moving on. Okay. This part is going to be very, very short when we talk about combustion reaction. What is a combustion reaction, guys? Combustion is a chemical reaction in which heat and light are created by a substance which reacts quickly with oxygen. Both reactions to combustion are exothermic to form carbon dioxide and H2O. Hydrocarbons undergo combustion. Okay, so here we're going to have, this one is a short one, I didn't delve too much into it, but this is a case where we have explosive, for example, fireworks, bombs, all of that, all of those are part of anything that creates fire. All of this is a combustion reaction because it ends up in a flame. So here we're going to have whatever we need, which is going to be our substance plus H2O, that gives us carbon dioxide and H2O. So this one is an example. It says complete combustion of propane in oxygen. Combustion of propane in oxygen. This is going to be our C3H8 plus 10O2. Okay, that will give us, sometimes what they can give you this side and ask you what the results will be. So you we'll have to automatically know that the result is going to be carbon dioxide plus H2O. So what you'll do, once you have something like this, you write your CO2 plus H2O, and then now you start balancing it out and see how many carbons we have. We've got 3 carbons, and here we've got 1. So you're already going to write your 3 there, and you're going to check how much oxygen you have. You're going to have 2 plus 1, it's going to give us 3. So now we need to put 10 there, because we need to balance out the H's. The H there is going to be 8, and here we only have 2, so we're already putting a 4 over there. So now when you calculate the oxygen, it's going to be 6 plus 4, it's going to be 10 oxygens, and that's how you balance out the chemical reaction. But we're going to get more into that later on in our lesson, okay? So for now, just understand what's a combustion reaction, what's an elimination reaction, what's a substitution reaction, and what's an addition reaction. Just to do a short recap, we mentioned our substitution reaction is where we replace molecules with one another. We do not change anything. And when it comes to a addition reaction, is when we take two unsaturated molecules and add them into one saturated molecule. What is an elimination reaction? Elimination reaction is when we take a saturated molecule and we break it down into smaller unsaturated molecules. And then we've got our combustion reaction. This is where you have your substance that's going to react with oxygen atom to form carbon dioxide and water. Okay. So this one, it's more of a substitution reaction because all of them are there. You're balancing the both sides. You do not change anything. Okay. You just substitute them into different spaces. Okay. So now we're moving on to our favorite part, which is our revision work. So this first exam question that we're going to be working with today is going to be the May-June 2019 Department of Basic Education exam. Okay. So this is the people that we're rewriting the exam, but it's very much important because these are questions that could be asked at any time. Okay. So what they say here is propan 1O. Okay. So we already know on the first propanol. So propanol is going to have 3 C's, right? And on the first one, which could be either on the beginning or on the end, will have an OH, okay? So it's a propanol. Okay, undergoes 2 different reactions as shown in the diagram, okay? So reaction 1 has HCl, and then you have your compound, and reaction 2 will have our H2SO4, and we'll have our compound, and reaction 3 will be a continuation H2O or concentrated H2SO4, and we'll have our compound Z. Okay, so what do we know about this, guys? Remember what we spoke? Remember when I told you guys, grade 12, that you guys need to understand you need to know each catalyst and what they are used for in order for you to understand what kind of reaction takes place. Okay, so now they want to know 4.2.1 type of reaction represented by reaction 2. Okay, so let's move and see. Okay, so here it says H2SO4. So reaction 2, when we check here on our dehydration, we have our H2SO4. So this is a dehydration reaction. Do you see, guys, how these things can come in handy? Okay, so here it seems the first part of these questions I didn't do it. Okay, I'm doing the second one. So this is a dehydration. As you can see here, 4.2.1 is a dehydration reaction. So now they want to know 4.2.2. The function of the concentrated H2SO4. What is the function of this? What did you say this is, guys? Remember we spoke about a catalyst being used to speed up the reaction. So the function of this H2SO4 in this reaction is to act as a catalyst, but not change anything, not change the chemical that is it's catalyzing. Okay. Yeah, so you see catalyst, dehydrating agent, causes dehydration, removes water molecules. So it could be any one of those, as long as it speaks more about the fact that it's a catalyst. Okay. So now that we know 4.2.3, the Iupac name of compound X. Okay. So we have here our compound X. Okay. So they want to know what's the Iupac name of compound X. So which means that you're going to draw your propanol with the 3 C's, and then you're going to remove water from it. And what you're going to have is the resultant. Okay. It's going to be a prop 1E. Okay. Because when you remove the H2O, there's going to be a double bond that forms. So remember we spoke about when in a dehydration reaction, what we do is we're turning a saturated molecule, which is a single bonded molecule, into a unsaturated double or triple bond molecule. So in this case, it becomes a propentene. Okay, prop 1E. Okay, so you can write it either as prop 1E or 1-propene. Okay, so it could be either also. Guys, we're doing this problem so that you guys can understand how our questions are going to be asked in the exam and how you need to answer them, and how you also need to filter out how you understand your theory with regard to your practical transcripts. Okay, so on 4.2.4 it says the structural formula of compound Y. So there we have our compound Y. Okay, so they want the structural formula. So let's go and check out our structural formula. So this is what we're going to have. So what does this mean? Because we have our propanol and we had our plus HCl, this will give us, this becomes an addition reaction, right? So from there, we're going to have propan 1 plus propanol plus HCl. It's going to give us this thing here. So we're going to have, get a mark for putting the whole structure in there, like 1, 2, 3 for propanol, and the H is there, and we're going to substitute the OH with a Cl. Okay, so this is substitution reaction. So only functional group correct, you get it, you're going to get half a mark if you only get the functional group correct. But if you get everything, the whole structure correct, that's where you're going to get your whole 2 marks for your structure. Okay. So now the type of reaction represented by reaction 3. Okay. So this looks like an addition reaction. Why? Because we've got H2O. So we're taking this compound, we're adding H2O into it to form a new product or compound. Okay. So let's see what they say here. Yes, it is an addition or a hydration. Okay, because we're adding water. So it's not a hydrogenation. No, it's a hydration. You're thirsty, you're getting some water. So you form one compound, you become one with the water. That's what you have there. So type of reaction represented by P is a addition reaction, or you can say hydration reaction. Either one of them, you'll still get the correct answer. So what's the Iupac name of compound Z? Let's go and check out compound Z. Compound Z is going to be propan 2-ol. Okay, it's gonna be propan, 2-propanol. I prefer basically to write it as 2-propanol. So I think it's also going to be good for you guys to learn to write it as 2-propanol, because once you write 2-propan, 2-ol, sometimes it can get confusing. You can end up putting the 2 before the N, or you might spend a lot of time getting confused on where the 2 is supposed to be within this letters. So it's always best, guys, for you guys to write 2-propanol, okay, so that you guys can understand. So these are your exam questions, grade 12, that you guys need to understand and familiarize yourself with, okay. So we're moving on to the next one, guys. If you check here, you see the problem that we did here. It's May, June 2019. It's question 4. If we check again, now we're going to be doing November 2019 exam. It's also question 4. So which means that you're likely going to get this problem mostly in question 4, because they never really change the structure of the paper. Guys, here we are working with paper 2, right? We are not on paper 1. This is paper 2, your chemistry paper. So do you see how much marks this count? It might be 70 marks, etc. But look at the mark allocation there. It's 12 marks for this entire problem. So that's a lot of marks that you will really need in your examination. So now we're moving on to the next problem. It says the flow diagram below shows how compound A can be used to prepare other organic compounds. So the numbers 1, 2, 3, and 4 represent different organic reactions. Okay, so that's similar to what we just did now, right? So we've got number 1. You can already see what's happening here, right? Because you've got your concentrated KOH, you've got all of that. They've written hydration, they've given you this one. So now let's go and check out the question. So primary alcohol, compound A, and this becomes this molecule. It's going to be propane. Is propene. It's going to be propene. This is propene. Okay, 2 propene. Or 1, but it's 2 or 1 propene. Okay, so it says use the information in the flow diagram to answer the following question. They want you to name on 4.1, name the homologous series to which compound A belongs to. Okay, so they want to know. So now we're going to see it's going to be a haloalkane. Okay, this compound here is going to belong to a haloalkane or alkyl halide. Okay, but I'm sure you guys still remember this from the time when we did our grouping, our functional groups, which we did 2 weeks ago. So that's what you're going to get for 1 mark. Make sure, guys, you either write haloalkane or alkyl halide. Those are the important terms, and you will get your 1 mark from that. Okay, so 4.2 says write down the type of reaction. Write down. Oh, I'm sorry about that. Oh, guys, and by the way, please don't be afraid to ask any question. If you're getting stuck anywhere, you just let me know on the chat, and I can explain it to you guys, so that we make sure that we're all on the same base. If you're still getting confused with some of this work, you can just send me a chat, and I'll go back and explain where you're getting stuck. Okay, and we can always go back and reference from the summary that we've already done. Okay. I'm just trying to see where I am. Okay, so it says here on 4.2, write down the type of reaction represented by 1, which is this one here. Okay, they want to know, want you to write these reactions over here. And our number 4. Okay, Write down the type of reactions represented here. So here we already can see that this is a elimination reaction. Remember we said an elimination reaction is where we take the one where we take saturated molecule and we turn it into an unsaturated molecule. Okay, and also we get to check this part here, the type of catalyst. Then we go back here. Remember what we spoke about. This is our elimination condition, the type of catalyst that is used in an elimination reaction, and this is our dehydrogenation. Okay, a haloalkyne. Okay, I'll tell you just now. I'm just trying to get to the next page. Okay, how do we know that it's a hydroalkyne? Because here, as you can see here, when it's added with the base, it gives you a primary alcohol. Okay, so anything that has a alcohol part, it's going to be your hydroalkyne. Okay, it's going to be your haloalkyne because it's got our alcohol. Okay, you can even see here they use concentrated KOH to break down the bond. So basically what you do when you find these reactions, you need to be able to make sure that that you check out what kind of a catalyst is used in this reaction, and if it's a haloalkyne, you'll know that it's an elimination because it's got either Br or it's got a, and if it's got a K, the one that has KOH is the one that will usually be your hydroalkyl, right? So this will be removed and it will give you an alcohol. And you can see here, look at the results here. Once you do a dehydrohalogenation, the one product that you're going to have is going to have NaBr plus H2O, and you will have a double bond where you had your halogen and where you had your hydrogen. Okay, so that's why it's a hydroalkyl. Okay. Oh, I'm glad that you are understanding. Okay. So that's our hydroalkane. So I hope that you also understand. I'm just trying to go back. Oh, okay. So there we have it. So now here we already mentioned that this is a elimination reaction because this is what we're going to have as our single bonds, our double bond. So it means if this gives us a double bond, it means that this one here had single bonds. Okay, so it was broken down like this is basically the definition of a elimination reaction where single bonds, which are saturated bonds, form unsaturated bonds, which is or triple bonds over here. And then on number 2, now we got number 3. It says that here we got compound A, and what we have is a primary alcohol. So what does it mean? What kind of reaction took place here? It's going to be a substitution reaction. Why is it a substitution reaction? Because here, the reason why this is a substitution reaction is because now we've got a primary alcohol, but before we had our halide, and which means that our halide, which could have been a Br or a Cl, it was replaced with our OH. Okay, so that gave us our primary alcohol. So we changed the whole formation. It moved from a halogen into a primary alcohol. I hope that you understand. If you don't, once again, Just let me know in the chat and I'll explain it again. So that's the difference that has happened here. So that's why it's a substitution reaction. A substitution reaction is the only reaction that can change the functional group, okay? Because there you're taking one and you're replacing it with another one, okay? So then now that we have our primary alcohol, we need to find out what is our compound C. And our compound C in this case is going to be esterification. What is esterification, guys? Remember we spoke about esterification? I might have to go back just to make sure, just to give you guys a reminder of everything that we've worked with. It was there. So remember, it says esterification is a substitution reaction that creates esters. Okay, so in this case now we are creating an ester. Okay. Okay, so there we have it. So this one is going to be our ester. So you know this sign, right? This is our form of a ester. So this is our esterification process. Okay. I hope we are in line. If you get confused, let me know and I'll explain again. So now they talk about considering reaction number 3, which is this one here, where we said it's a substitution reaction. It says, write down the 2 reaction conditions for this reaction, okay? So we need to write the 2 conditions for this reaction. What's most important is for us to understand how we need to write it in our exam as grade 12 for us to get marks, okay? So they say write 2 reaction conditions. We are not writing reacts, so please don't make the mistake of trying to compile reactions for this. They just want the conditions, okay? So I want us to go back to substitution, right? The best way to explain is through substitution. So they said here, remember when we did our introduction to substitution reaction, it says substitute the chemical reaction in which an atom or a group of atoms is substituted by another atom or group of atoms in the molecule. Only under, I need to highlight this, I didn't highlight it before. It says only under 2 conditions can a substitution reaction take place, right? So that's what they want now in that question. They say only under 2 conditions: in the presence of sunlight or ultraviolet at a temperature between 25, sorry, it's not 2005, it's 25 degrees Celsius and 45 degrees is a substitution phase possible. The hydrogen atom is substituted and alkanes by a halogen atom to form 2 compounds, one in which is a haloalkyne and an alkyl halide. Okay, so in the presence of sunlight and at a very high temperature, so we know it's heat and high temperature. Okay, so let's go and try and answer that question today. Okay, so the 2 conditions, it's very high temperature between 250 degrees Celsius and 450 degrees Celsius, and the other condition is that it has to be a heat, sunlight, or ultraviolet ray. Let's see. So you see, it says here, where there's heat, or dilute strong base, or add water. Okay, so these are all the conditions that we're going to use. So here they wrote, you see, there's many ways to kill the cat. Here they wrote about the heat, which is what we already spoke about, but there must be a strong base. And where would you get that from, guys? We're working with number 3, right? So sometimes you do not have to think of many things. You just need to think of what you have here. They gave you compound A, the primary alcohol, and they gave you a base. So already you know that the condition for that to have taken place, there had to be a base, okay? So you can just write that a heat and a base. So you take what you see from there that need a base. Here we would have said in the presence of a catalyst of concentrated KOH. So sometimes you just need to look at what you already have on your problem and use that, and also the high temperature. So those are things that you will require. So sometimes grade 12, you need to always have a mind that thinks beyond the box so that you can get the correct answers. All you want now is to get you guys ready for your exam so that you know how to answer the questions. Okay, so now they want to know the Iupac name of the primary alcohol that is formed. Okay, so they want to know the primary alcohol. I think it's probably propanol. What do we look at when we look at this? We start checking out what you had before, okay? Because here we removed our H's. You look here what you had before. So you had 3, and now you've got an alcohol. So it's likely to be a propanol, right? Yes. So you see, it's propanol because everything in this diagram gives you a clue of what we are working with. Okay, so because here we've got 1, 2, 3 carbons, it means that here we also have 3 carbons, but in this case we've got an OH, so it's a propanol, like I just mentioned. Okay, getting stuck? Let me know, I'll explain again. And then the next part, 4.4, it says draw the structural formula for compound B. Okay, so here, remember what's happening here, guys. Now we've got this double bond. This is an addition reaction. How do we know it's an addition reaction? Because here we've got an unsaturated. We've got many conditions that tell us that this is an addition reaction. I just want to highlight the first part that we see is an unsaturated hydrocarbon, right? So which means that it's got double bonds, and we also have a catalyst. It's written here that this is a dehydration reaction, and we know from our theory part that our hydration is part of our addition reaction where we add water. We add H2O. So our catalyst here is going to be our H2O, or it could have been H2SO4 or HP, but here they said hydration, so we assume that it's a H2O because in hydration is where we add water into our form, and we change to form saturated compound. Unsaturated compounds are broken, are added into one compound. Okay, so if we're going to draw this one, we're going to break these bonds here, right? So here we're going to have OH, we're going to have OH, and the other one is going to have an H. So one H is going to come here, and then here we're going to have an OH. So it's going to also give us something like propanol. Okay. Okay, so let's go and see the structural formula. Okay, so here we have it, right? Like to you guys, still have our 3 C's. We added because we had a double, right? So this one here, we added our H2O because it's a hydration reaction, and we added this. So you see, this is H2O. Okay, because remember here before, we didn't have the 2 H's and the O. We didn't have the 2 H's and O. Here there was a double bond. So we split them up and we put the H2O over here. So once you have this whole structure, you will have your 2 marks. But if you only have the functional group correct, for example, if you have the C's, then you're only going to get half a mark. You're not going to get everything. So you need to have your complete structure to get marks. Okay, so accept OH as condensed. So you see, for grade 12, you need to have this condensed like this. When you do, when we do revision, we sometimes write OH here, but they prefer in your exams for grade 12 that you write them condensed like this, okay? Then you have your molecular formula. It's functional group, and if more or one functional group, it's 0. So that's how you get your complete structure over there. Then we're moving on to the next problem. It said, consider reaction 4. Yeah, 1, 2, 3, 4. This is our reaction 4. Remember we spoke about an esterification. Okay, so this is our esterification. This is an ester, guys. You see the co. Once you see COOH, you'll know from our previous lessons that the co is an ester. Okay, so what we consider this one, right? We had our primary alcohol and now we are esterifying it. Okay, so what is the structural formula for organic compound C? For our organic compound C, and name or formula of the catalyst that is used. Okay, so let's go to the structural formula first. So you see what happens now? Okay, so you get our positive marks. Yeah, so this is going to be our compound because this is now an addition reaction. Remember our esterification? We're going to add our ester, which is this one that was given here, and we already had our propanol, and this is our ester, right? Because we had two C's, H, and the OH, right? So when it gets here, minus the H, right? And it becomes an O. So this is something like an addition reaction that took place here, and esterification. Okay. So this one, you see, we wrote it the way it is. Going to be our CHHOH, but we had already combined it with what we had. We had propanol, our primary alcohol, and we added this one here, and this gave us our ester. Okay, so when you do the whole structure correct, this is what you get. But if you only get the functional group correct, which means that if you get this part correct alone, that this was an ester, you might get half a mark, but be aware that your mark that you're going to get is going to be according to how much work that makes sense, because you can't just write the propanol and expect to get a mark because of a functional group. That is not a functional group. That is completely wrong. So let's make sure that we get it right. Okay. Okay. So let's go to 5.2. Name or formula of the catalyst that is used. So now let's go back and see the catalyst that is used in this case. What do we know about this kind of formula, the esterification, is that we need a concentrated sulfuric acid. Usually, we're going to use a concentrated sulfuric acid. Guys, sulfuric acid is a catalyst that we use for most of our reactions, okay? So be sure that you use them. You always remember how it works out, okay? I just want to check from the substitution reaction. Yes, especially when it comes to this part here. When you do addition reaction, there's always H2SO4. When you do elimination reaction, there's always H2SO4. So that is one most recommended catalyst that can be used in the problem that we're using here. Okay. If you have any questions, just let me know so that we can go back. So before our time is up, I want us to do the November 2018 exam as well. Okay. Please, guys, take out your pens, try and write them down. If you get confused anyway, you just send me a chat and I'll try and explain it backwards. Okay. So it says here, 3 reactions of organic compounds form from the same homologous series as shown below. Okay. So we've got butane plus Br2 gives us 2 bromobutane plus P, right? Okay. And number 2, it's going to be a pentane plus excess oxygen. And then plus heat. Already that one, you already know it's a combustion because it's got excess oxygen. Remember, O2. And then this one is an hexane, and it gives you the CH4HQ. Okay, guys, let's go back. Before they even ask us a question, we know what each one of them is, right? This one is the butane, and this one is the bromide, okay? And it says here, 2 bromobutane plus P. What reaction do we already know this is? It's a substitution reaction, right? Because remember what they said in our substitution reactions? Always based when we go back to the theory. It says here, the number of products and reactants are equal. If you have 2 reactants, you will have 2 products. Okay, so you have 2 reactants and 2 products. They might not be the same because they have swapped or replaced some of each other's positions. Okay, so that's why I say this one is a substitution reaction. So this one is a substitution reaction. It's a butane plus Br2. So it's a halogenation. Okay. And then number 2, we've got pentane, but I already mentioned this is a combustion reaction. And this one, it's a from 1 split, it's an elimination reaction. Because you take hexane, you make it into smaller parts that are much more useful. Remember, that's our explanation that we had for our elimination reaction, which is our cracking. This is the cracking, is a mechanism by which hydrocarbons are eliminated, making chains from longer ones shorter and more useful. So this is a cracking procedure, right? Okay. So after you've written down and you're clear of what you know and what you don't know, now we go to our questions. Okay. So it says define homologous series. Oh, okay. Homologous series is a series of organic compounds that can be described by the same general formula or functional group. Okay. So functional group and homologous series means the same thing, guys. Please make sure that you understand these terms. They could have asked you what's a functional group. You would have still given us this same thing. Okay. So it's a series of organic compounds that can be described by the same general formula. So in this case, for example, with alkanes, you know they all have single bonds. They can be longer or shorter chains, but they will all have single bonds. And you know, with alkenes, they will have double bonds somewhere along the chain. So that's what it means when it says a series of organic compounds that can be described by the same general formula. Okay, so that's your 2 marks just like that. Right in the functional group, same general formula, a series of organic compounds. Okay, so now they want to know in 4.1.2, name the type of reaction represented by number 1. Okay, what did I say, guys? Number 1, we already wrote it. So we're just going to plug it in and say substitution reaction because we've already established that before they even asked the questions. Okay, so write down the formula of the inorganic compound P. So here, 2-bromobutane. This is going to be HBr. I think it's HBr. Yeah. 2-bromobutane. That's going to be HBr because just substituted 1B with 1 H on the butane. So it's going to be HBr. Okay, I'm just trying to read a bit faster as I see that we are slowly running out of time. But I hope that you understand. If you're getting stuck or you don't understand how I got to HBr, just let me know and I'll explain it again. So 4.1.2 says, give the structural formula of a positional isomer of 2-bromobutane. That's taking us back to last week's lesson where we did our chain isomers, positional isomers, and our other isomers. Okay, so if this is a positional isomer, it means we're changing it from one position to another. Okay, so we're taking the butane from one position to another. Okay, So let's see. So you see, this is a positional isomer. You could take it from here and move it there, or move it there, or move it there, because it's an isomer. Remember what an isomer is, guys. Go back to your terms that we did last week, and you'll understand. We've got 3 types of isomers. We've got the chain isomers and positional isomers and structural isomers. Okay, so each 2 or more compounds with the same formula but different arrangement of atoms in the molecule and different properties. Okay, so that is our isomer. I wish I had last week's page where we did our isomers. I'd be able to reference back, but I do not have it today. Okay. So our positional isomers, that they have the same carbon skeleton and the same functional group, but differ from each other in the location of the functional group. Okay, so like I told you guys, that because it said positional, you see before they gave us two bromobutane. So now it means the bromo, you can put it on position 1, position 3, position 5. That makes it a positional isomer. Okay, so using molecular formula, write down the balanced equation for reaction 2. Okay, so here we know it's pentane plus excess oxygen, but how are we going to do this? Remember what I spoke about when I talk about combustion. I said anything in a combustion reaction, our result is H2O plus O2. Okay, carbon dioxide, CO2, going to be CO2 plus H2O. So once you have that, then now you can start balancing out. We know pentane is going to be C3. Yes, it's C3. No, it's C5 and an H equivalent. Okay. I just don't have anything to write today. I'll be able to write it down so that you guys can see, but you'll see it now when you do it. So you're going to write pentane, and then excess oxygen is going to be O2. And then here we're going to have H2O plus CO2. So the result of a combustion reaction is always carbon dioxide and water. And how do you recognize a combustion reaction? When you see excess oxygen or O2 or oxygen, etc. Anything that's added to oxygen or O2 will give you a combustion reaction. Okay, so let's see how it looks like. Here we are. So you see what I mentioned to you guys. You're gonna have your C5H12. What's good if you guys want to be able to get your pentane much quicker? What you need to do is draw it. Just draw it fast and say, put your 5 C's and put all your H's, and then count the number of H's, and you'll know it's going to give you 12, and the C will be 5. Oh, sorry about that. And then it's going to be plus O2 will give you carbon dioxide plus water. So once you have that skeleton, now you need to balance them out. You need to count how many carbons do you have. You have 5, and here you only have 1. So already there, you write your 5. And you check your H's. How many H's do you have? You have 12. And how many do you have there? You've got 2. So what do? You put a 6 there, and that's going to be 12. So now you balanced out the C5 and the H12. But now your O2 is not balanced. So what do? You calculate how many O's do you have. So here you're going to have 2 times 5. It's going to give you 10 plus 6 is 16, right? So here you only have O2. So for you to have 16 oxygen, you're going to put an 8 over here. I hope that this makes sense, guys. So that's basically how you're going to balance your equation. Okay. And that is 3 marks, guys. 3 marks is a lot. Make sure that you get that right. Okay. So what else do they want to know? We're almost running out of time. We only have 6 minutes left. Reaction 3 is an example of a cracking reaction. Remember we spoke about that? Remember, that's why I told you guys it's very important that you name all your reactions before you start your problem. Okay, define cracking reaction. We know that it's when hydrocarbons are broken down, when long chains of hydrocarbons are broken down into smaller and shorter chains for them to become much more useful. Okay, that's what we know about this definition. So I hope that you're not going to have a problem with describing it in an exam. Okay, because this is 2 marks. 2 marks is a lot. All these marks are a lot. You need to catch them all, and 3 marks if you understand your work. So 4.1.7, it says give the structural formula of organic compound Q. Okay, so hexane is 7, right? So if you have 2 there, you minus 2, it means that you're going to have C5 already. We know it's going to be another pentane. Okay, so when you have our pentene, yeah, it's going to be a pentene. But let's check out how we need to draw it as a structure. Okay, so I wanted to know, give the structural formula of organic compound. Yeah, it's a pentene, like I mentioned. See, 1, 2, 3, 4. Oh, it's a butanol. The 1, 4, 5, 6. Oh, hex is 6. Sorry, guys. Hex is 7. Hex is 6. You see how easy it is for you to make a mistake when it comes to naming all these problems. So if it's going to be butyl, you're just going to draw it as a chain the way it is. Okay. So let's see what's the next problem. The one okay. Study the following diagram below. I want us to do this one quickly before our time runs out. Okay. It says 2-bromoputane hydrolysis. Hey, hydrolysis. Remember when we did hydrolysis? We did hydrolysis in the substitution. Gosh, guys, I just want to make sure that you guys understand everything, okay? Remember where we saw our hydrolysis. There's our hydrolysis in our substitution reactions, okay? Let's move fast. Our time, we only have 3 minutes left. Okay, write down the Iupac name of compound R. Okay. Okay, so this is going to give us butanol, or you can write 2-butanol. Don't write it as, like I said, it's better to write 2-butanol than write butan 2-ol, because you'll never be too sure where you need to put it, especially when it comes to an exam. You're not sure whether to put in front of the N or in front of the O. So it's much more important for you guys to write as 2-butanol so that you guys can understand. Okay. And then 4.2.2 says compound R reacts in the presence of concentrated phosphoric acid to form an alkene. Okay. Write down the structural formula of the major product in this reaction. Okay. Now we're moving forward. This is our last problem. Oh, here we go. Oh, guys. Unfortunately, we couldn't do. I wanted us to do this November 2017, but you guys can try it at home. You can try and do this problem. Who knows? Maybe we can do some problems on next week when we come back on Saturday. We can do one of the problems from that paper before we do our lesson. Okay, so here is our butanol, and this is how it will look like. But they mentioned they wanted us to write the major products in this reaction to make an alkene, and this is our alkene. This is how our alkene will look like. It's going to be our butanol on our number 2. It's going to be our double bond. Okay, so this is a elimination reaction. So that's what we're going to have. And that is, look at the mark allocation. That is 17 marks. Okay, guys, thank you guys so much for a beautiful lesson. And thank you guys for joining this class. Please make sure you join me again next week for another, yet again, interesting class. We're going to be doing, we're still doing matter and material. we're going to be doing, we did organic reactions, we're going to be doing plastic and polymerization, and then we're going to be done with matter and material, which took quite a lot, because it's quite a lot of definition and theory and all of that. But thank you guys so much for joining me in this classroom. My name is Nonkululeko Madondo, and I am a teacher for physical sciences. Thank you and goodbye.